Symmetry. How can we take advantage of symmetry? So if we know a curve's symmetric, then essentially we really only have to draw half of it, because then by symmetry we get the other bit straight away. So it can help. And there's two types of functions that are very symmetric. Our odd functions, and there's our definition for an odd function. If function negative x is equal to the negative of function x, and that is actually very similar to something we saw yesterday. You see, it ends up having point symmetry about the origin. And when you look at it, oh yeah, because we said point symmetry is when we replaced the x with the negative x and we replaced the y with the negative y, and you sort of ended up with y equals negative function negative x. And if you look at this, I could rewrite this to make function x equals negative function negative x. It's the same thing. So odd functions will have that symmetry about the origin. Now consequently, what does that mean for the curve? Tell me something you can now tell me with 100% certainty about an odd function. What does that now mean? If we know it has point symmetry about the origin, what can you say with 100% certainty about any odd function? It's either going to be discontinuous at x equals 0, or it'll go through the origin. Because if it's got rotational symmetry, then when it rotates, the origin is going to stay there. And the only situation where it wouldn't do would be like, say, the hyperbola, where it's discontinuous at the origin. So you can still rotate, and that's not an issue. So if you spin it at 180 degrees, the picture will look exactly the same. Y equals x cubed would be an odd function, and we can see it there. Yep, sure enough, spin that 180 degrees, we'll get the same picture. Hyperbola, yep, spin it 180 degrees, we get the same picture. In fact, something like this, x to the power of 7 minus x to the power of 5. That would be an odd function. If you spun it at 180 degrees, you get the same picture. This one also would be an odd function. In fact, when you're dealing with polynomials, if all the powers are odd, you'll get an odd function. And in fact, even with the negative indices as well, if you get a negative odd number, it's got to be an odd function as well. Of course, that's not good enough for proving it's odd. You can't just look at it and say, oh look, all the powers are odd, therefore it's an odd function. We have to show it satisfies the definition. Okay, so function x, x cubed plus x to the 7, what do I get when I substitute in negative x? What does function negative x become? Alright, we sub the negative x in. Well, if I have a negative number to an odd power, it will always be negative, in this case, x cubed and negative x to the 7. That is indeed the negative of what we saw for function x. So yes, it satisfies that definition. Now, yeah, that is an odd function. Well, the other type is even functions. And the definition for that, function negative x is equal to function x, and again, that is something we saw yesterday. This time, it's going to have line symmetry about the y-axis, because we said when we replace x with negative x, it will reflect in the y-axis. So if we've got both of them and they're equal, then when we reflect, we're going to get the same thing. So the y-axis turns out to be an axis of symmetry, like our parabola over there, y equals x squared, for instance. Now y equals x squared, yep, x squared plus 4. I mean, if we shifted that up 4 units, it's still going to be reflected in the y-axis. That one would as well. In fact, this one would also turn out to be an even function. In fact, again, when we're dealing with polynomials, if all the powers are even, it's got to be an even function. And for the sake of it, constants, of course, we're thinking x to the power of 0, and we say, well, 0 is an even number, so it works. So if I have to prove it's an even function, there's the function. Again, let's investigate what happens when we substitute in negative x. If I square a negative number, it's going to become positive. So x squared plus 4, oh look, that is the same as function x. Therefore, we do have an even function. So let's just recap. We've got our parabola over here, even function, our cubic, odd function, our hyperbola, odd function, our circle. Ooh, what type of function? Very good. And I saw you say it over there as well. You shook your head and went, hang on, it's not a function. So it's not odd or even, because it's not a function. It doesn't satisfy the first criteria. It has to be a function before it can be an odd or an even function. Okay, so 4C.